In this video, we will explore the dodSON.Core.Packaging and the dodSON.Core.Installation namespaces. We will start by creating a console application and making a reference to the dodSON.Core assembly. First, we will create a function that will create a package provider. The package provider provides methods to create and connect to packages, iterate and find packages, and read and write package configuration files. The package provider takes a file store, which is the source for the packages. To learn more about file stores, please see the Programming with the dodSON.Core File Storage Namespace video and the dodSON library help file. The name of the configuration file inside a package, and a serializer used to read and write the configuration file. Finally, it takes a PackageFileStoreProvider, which facilitates creating and connecting to packages within the file store. Next, we will create a function that will create a package. This will take a package provider and use it to create a package with the specified name and version and the created package configuration. The package configuration takes the name and the version of the package, whether the package is enabled, its priority, which determines the load order of the package. The lower this value, the sooner the package will be started, whether the package is a dependency package, and finally a list of packages this package depends upon. To learn more about creating packages and adding files to packages, please see the dodSON software library help file, dodSON.Core.Packaging namespace, connected package class. We will use this function to create the non-dependency package A, which has a dependency on package X, version 1, and package Y, version 1. Package B is virtually the same as package A, except it has a dependency on package Y version 1 and package Z version 1. Next, we will create the dependency packages X, Y, and Z, all versions 1 with no dependencies. It should be noted that dependency packages can also have dependency packages. It's simply not required in this example. Finally, we will iterate through all packages in the package provider's package store, then wait for the user to press any key so that they can view the results. Compiling and running the application shows the packages being created and then the list of packages. Next, we will install the packages. We will create an install log to record the actions of the installer. And we will create a package provider to service our packages. We will create a function to create an installer. The installer takes the installation root path where it will install the packages, the name of the configuration file inside each package, the serializer used to serialize and deserialize the configuration file, and a log source ID used when the installer generates logs. We will use this function to install all non-dependency packages and write any logs generated to the install log. The installation settings takes an install type, which determines the type of installation to perform, whether to do a clean install, whether to enable package mirroring, whether to remove orphaned packages, and whether to update original packages before installation. Finally, we will close the install log and wait for the user to press any key so they can view the results. Compiling and running the application shows the packages have been installed. We can see the package configurations along with their dependencies. The install log shows package A was installed along with its dependency packages, and package B was installed along with its dependency packages. Also notice that package Y was not installed twice, because package Y version 1 was already installed. Next, we will create package C with the dependency on a brand new package Y version 2. And create a new package Y version 2. Compiling and running the application shows the packages have been created and added to the package store. Viewing package C's configuration file shows that it has a dependency on package Y version 2. And looking at package Y version 1 and version 2 configuration files show they have the proper version values. Finally, we will install package C with its dependency package Y version 2. This will demonstrate a common scenario where package A and package B, along with their dependency packages, have been installed and are working fine. Now along comes package C with a new version of package Y, version 2. After installing it, highest version only mode, package B fails. Looking at package B's dependency chain, you'll see that it now references package Y version 2, the wrong package. Package B is now broken. We can patch package B to specifically use package Y version 1 if package Y version 1 is available by setting the specific version of the Y dependency in package B to version 1. This will tell the packaging and installation systems to try to use the specific version if possible. It is important to note, however not demonstrated here, if a minimum version is defined and that minimum version is not met, then an error will be logged and the package will be missing a dependency. The installer provides many enumerations, including ones to find packages with missing dependencies. See the dodSON.Core help file for more information. We will start by creating another install log and create the standard package provider and installer. Then we will use the installer to find and get a reference to the installed package B and use the package provider to find and get a reference to the packages package C and package Y. We will display package B's dependency chain And then we will install package C along with this new dependency package Y version 2. Installing it in highest versions only mode and removing the orphan packages will cause package Y version 1 to be removed. Again, we will display package B's dependency chain and then get a reference to the installed package C and display its dependency chain. And finally wait for the user to press any key so that they can see the results. Next, we will patch package B to use a specific version of package Y, specifically version 1. We will write the modified configuration file back to the package using the package provider. And use the installer to write the modified package configuration to the installed package's configuration file. Now we will attempt to reinstall package Y. First, we will install it using highest versions only mode, which will demonstrate that the highest versions only mode will not allow packages with lower versions to be installed over packages with higher versions. Then we will install package 1 in side-by-side mode. This will allow packages with the same name but different versions to coexist. Finally, we will display package B and package C's dependency chains, showing that each package now references the correct versions of package Y. Compiling and running the application shows package B's dependency chain correctly referencing package Y version 1. After installing package C with its dependency package Y version 2, we see that both package B and package C now reference package Y version 2, and that package Y version 1 has been removed. The install log recorded the installation of package C and package Y version 2 and the removal of package Y version 1. Attempting to install package Y version 1 in highest versions only mode shows that package B and package C still reference package Y version 2. The install log recorded the attempted installation and shows an error stating that the highest version only rule will not allow installation of the lower versioned package. Finally, we attempt to install package Y version 1 in side-by-side mode. After successful installation, we see that package B's dependency chain references package Y version 1, and package C's dependency chain references package Y version 2. Package B is no longer broken and references the correct version of package Y, and package C correctly references the newer package Y version 2. Package C's configuration file shows it requires a minimum version of package Y version 2. Package B's configuration file shows it requires a minimum version of package Y version 1, and if possible, the specific version of package Y version 1. This video demonstrates some of the basic functionality of the dodSON.Core.Packaging and dodSON.Core.Installation namespaces. The packaging and installation namespaces provide a feature-rich packaging and installation system that is easy to use. See the dodSON Software Library help file for more information.